In this lecture, we are going to have a look at man-in-the-middle attack. This is perhaps one of the oldest and the most effective attacks in cybersecurity. So the concept is really simple. Between two legitimate end systems, there is a man in the middle and who is exploiting the relationship between the two end systems. And all of the traffic, it passes through this man in the middle, and then he can copy or modify this information without the end systems being even aware of it. So let's discuss man in the middle attack in more detail. It's a broad class of attacks with lots of different possibilities. So for example, the man in the middle could just replay traffic and simply copy sensitive information such as browser session information, passwords, or credit card information. So in this mode is a passive attacker. He is not actually modifying any of the traffic, and it is almost impossible to detect these kind of attacks because the attacker is not leaving any footprint. He is not modifying packets or IP addresses or anything. He is just simply copying information. Now these type of passive attacks are much harder to detect and block. Another possibility is that the man in the middle is replaying traffic after modifying the traffic in order to achieve anything. For example, he could inject malware in the packets, he could send spoofed IP addresses or many other things. But in this case, the attack becomes active and the attacker is leaving a footprint, making it slightly easier to detect and then block it. Next, we're going to have a look at some of the techniques used by man in the middle attack. So the first and the most popular is IP spoofing. IP spoofing refers to masquerading as someone else using their IP address. So basically in your packet, if you change your source IP address, you can insert whatever you want. And now that address will appear as coming from that actual IP address. So this is IP spoofing. Another is DNS spoofing. In this, the attacker tricks users into visiting malicious websites thinking they are legitimate. So the basic idea, as we discussed previously, was that an attacker sends DNS reply messages with fake IP addresses or IP addresses which point to their domains. So basically the user thinks this is the legitimate domains, and when they visit that website, they're actually visiting a malicious domain. The third technique is SSL hijacking. So when you're visiting an insecure website on port 80, as we discussed previously, the HTTP protocol, it runs on port 80 and it's considered insecure because it transmits data in plain text. So all of the communication between the client and the server will be in plain text, which can, make it very easy to eavesdrop, steal information, and masquerade. So now what happens is that if you visit an insecure version of the website is going to automatically redirect you to port 443, which is HTTPS, which uses the TLS encryption in order to make the end-to-end connection secure. Now the problem in SSL hijacking is that the attacker intercepts this precise point when the website is redirecting you or the server is redirecting you to a secure version, and they basically trick users into being redirected to their own malicious domains. The last one is email hijacking. A malicious user somehow gets access to an email account and then silently monitors it. And at an appropriate time, he crafts a fake email to, for example, they can send an email to the bank posing as the customer. So in this type of attack, the attacker is observing the email account and communication in order to learn more information to launch a more sophisticated attack. So these were some of the techniques used by man in the middle attack. Let's explore some of the mechanisms which we can leverage to prevent man in the middle attacks. So for wireless access points, you could always use strong encryptions, such as using WPA2, which makes sure that the communication between the client and the wireless access point is encrypted. Similarly, for wired networks, you should always use secure mechanisms such as VPNs for remotely accessing your backbone corporate network. Now, VPNs or other similar mechanisms, they create a secure encrypted tunnel which makes your end-to-end communication secure, making it very hard for people to insert themselves in between the communication and acting as man in the middle. And you should always use HTTPS instead of HTTP because, as we discussed several times, HTTP communicates using plain text. So always use HTTPS to encrypt the end-to-end communication so that the communication between client and web servers or the websites is secure. You should always use authentication mechanisms, and you should leverage public key cryptography because oftentimes the client and the server, they don't have a mutually shared private key. So that's why you can leverage public key cryptography to initiate the communication. And then once the communication is done, you have a secure tunnel. You can obviously move on to using private key in order to have a more efficient communication. That concludes our lecture. I'll see you in the next lecture.